Hey, what's going on? And Josh, this is fun. We get to do this again.
Oh.
Yeah, no, it'll be fine. It'll be fine. Everyone will enjoy it. Trust me. It's all right. We got a lot to talk about today. We're gonna dig into some Spring code. We're gonna dig into some Cassandra data modeling. Josh and I have been talking about this for a while, and I think we have a pretty cool setup today because we're gonna walk you through some beginning to end. The live coding is going to cover a lot of the stuff that you would normally want to, when you start using Spring with Cassandra. There's just some things you want to learn, and we're going to have some fun with it too. Like more of not just like here's how you do it. It's going to be like, why would you do this? And I think that's kind of important because just copying and pasting is not the way to write code. You want to understand it, and there's a lot of reasoning behind some code that you write for Cassandra, but let's face it, we want to have really highly scaling, efficient code that doesn't break. And Josh, I think that's kind of the name of the game today. What did you say?
Yeah, and also the name of the game a decade ago, because as I'm sitting here listening to you, I'm just realizing that when Netflix originally talked about the cloud native architecture, they were talking about microservices built on Spring, talking to Cassandra. That's what Adrian Carcroft and the team were talking about back in 2009, 2010.
Yeah, that's right.
And so there's a reason. It's a good combination.
Right. Yeah, it's a great combination. And it's it's interesting because a lot of folks say that Cassandra was 10 years too early. Maybe not. I mean, thank God it was there, or else we wouldn't have Netflix and, Tiger Blood and all the other things that we have. But I mean, I think of like what Cassandra enabled then is more of what people need now every day, like a good example is we were talking about this before, but like in retail, Target has been pretty vocal about during the pandemic how they run their curbside pickup off of Cassandra. And as soon as the pandemic hit, they had to do curbside pickup like every day.
Yeah.
And like at a ridiculous scale. And it meant that, and this is what I love this quote. They said, we basically had a Cyber Monday every day.
Oh, there's more than one Monday per year.
Yeah, I like to think that.
So, and by the way, for those of you who are tuning in from the other parts of the planet, I don't know if Target's outside the country. I haven't really come to think of it. I haven't really seen it outside the country, but here in the States, it's everywhere. It is everywhere. It's a huge, just
a way to buy stuff. It's a retail store.
Yeah.
It's a huge chain in the U.S., but there are huge chains everywhere, and they probably have Cassandra in their stack somewhere.
Yeah, and Spring,
and a lot of smart engineers to glue it all together.
Yeah, exactly. Cool. By the way,
shall we get started on this?
Yeah, I'm
down. Well, I think the first thing we need to do here is we're gonna use Astra, DataStax Astra, which is a Cassandra as a service to get things going. So why don't we get our database set up, and then we can while that's spinning up, we can talk about a little bit about what it is, some data modeling topics, and then we're going to just jump right into some code. How's that work for everybody?
Sounds good to me. I think I need to set up an account. Is that the idea? Or I need to set up a database?
Yeah, so let's
Okay. Can do share screen.
That's my screen.
Sharing. Can you see? Okay. So wait. All right. Can you still see everything? We're okay. You are. Okay.
So you're going to start out by going to astra.datastax.com. Let's get that. And if you have an account on there, sign in. If you're going to do it, you use Google. Single sign on. So here we are. Now you already have a database set up in there that we've got in there. You want to just terminate it? Oh yeah, just get rid of it. Let's start from scratch here. So yeah, while this is terminating, so this is the dashboard for Astra. This is pretty simple. It shows you all of the things that are happening with your database. Because Astra is serverless, you pay for what you use. This gives you basically a snapshot of everything that is happening on your database. The writes, the reads, how much storage you're using, and data transfer. Those are all the components you pay for. So in a second here, when this terminates, we're going to go ahead and create a new database. And I think we could probably start now. Well, we'll see. It's always this is what happens when we do live code. It's like we got to do the setup first, right? But the process of creating a database, if you've ever used Cassandra before, or you haven't used Cassandra before, this is so lucky. Using Cassandra, just we can't hear Josh, can we? I think he's muted. Okay, I can't hear him. There you go. Click that button.
Can you hear me now? Oh, okay. Yeah.
Man, I was like talking like, okay, is Josh ever going to say anything? No.
I was speaking. I was like, oh, what's going on? Well, okay. Good thing I'm not the one.
Yeah, good thing you texted me and say I'm talking and you're not listening.
Yeah. Yeah.
Right.
Yeah. So Astra, tell me about Astra. First of all, we're logged into Astra magically. I've just terminated my instance. Astra is your hosted Cassandra. That's the thing. That's
right. And okay. Yeah, so if before Astra, there's different ways you can run Cassandra. Probably the most popular was up to this point was maybe running a container, so sure. Docker pull. Before that, it was download a tarball. Yeah. That sounds great.
So what is the like? I can still do those things, I guess, but what is using Astra buy me? Like, what's the? This isn't the vaccine, right? This is totally different.
That's AstraZeneca, right?
Okay.
That's very different. Yes.
Okay.
No, sure. not the vaccine, but it could be for your bad database experiences.
Oh,
do you see what I did there? See what I did? Yeah, I know. Well, it's meant to give you like any person, like especially developers, the ability to use Cassandra without having to run it yourself.
Right.
And cool. I think in 2021 we should expect that.
Yeah, I'm all about not paying for. I'm all about not running things that I can't charge for, basically. So, like, if I can't make money off of running Cassandra, if that's not my core competency, I don't want to be doing it. I'd much rather just pay somebody else to do that, right?
Right.
That's not the thing I am in business to do, right? In the same way that I'm not in the business of administering email servers. It's just not the thing I care about. I'm gonna delegate that to some other provider if at all possible, right? Whenever possible.
Yes, and I don't do puppet shows at my house. I rent Netflix.
Right.
Yes. Exactly. So let's go ahead and create a database then. Let's show how easy this really is.
Okay. What should we call it?
I think I like the Bootiful. I mean, let's stick with it works.
We're going to create a domain model having to do with customers and orders. So can we just use the Keyspace CRM?
Yeah, I think that works. And then you can pick whatever cloud. So we have Google Cloud and Amazon Web Services in here for now. Azure coming soon. But when you click provider, then you can then you also pick which region you want to be in. And this is just for the basic serverless. And as you get deeper into like more enterprise workloads, there's different options. But right now, like if you want to run Amazon East, there you go.
Well, as you and I are in the States, Amazon East is going to be proximal. But of course, relative to the world, you might argue that EMEA is fairly central, right?
Yeah.
Roughly midway between APAC and North America or the Americas. Okay, ready, steady, go.
Let's do it.
Get ready for liftoff. Oh, that's intimidating. I have to pay. That's what that's telling me, that I'm gonna.
Yeah, so you selected the pay-as-you-go plan.
Yeah.
For each person, you get $25 free of usage per month, and then there's a charge. You don't have to put in a credit card to get it going.
Right.
And it's pretty good for like a toy database if you want to use it all the time for various little things. It's well under $25. It's a pretty generous plan in that regard.
Cool. I'm down. Thank you for that. So it says pending. Okay.
Yeah. So let's switch over to some slides. It's what it's doing right now is it's setting up the infrastructure on the back end, and it takes a few minutes to do this, and you'll get a notification on email. It'll also show up on the screen. This is reactive, of course. So, but what I can do is, Cedrick, why don't you switch over to my share and let me know when you're there, and I'll walk through a little bit about what's going on.
You need to take over the screen sharing, Patrick, please. You need to share your screen now.
I do need to share my screen. See, it's a good thing Cedrick's here because we're a bunch of noobs. Yeah. All right, I'm going to share now. All right, is that better?
Yeah.
Okay, can you see us?
I can see it.
All right. But more importantly, does everyone else see it?
Yeah, it's coming. Yeah. Let's get rolling.
Okay, let's get rolling. All right. So I just want to make sure, big shout out to Josh. Thanks a lot for showing up today.
Thanks,
you need to get a hold of him. Here's all your coordinates. Go find Josh.
I work on the Spring team. I've been there for 10 plus years. It's just I have a Spring source email and all that stuff from the old days if I needed it, but just that one's nice and fixed and it stays steady. So my direct messages are open. So should you have questions, when ineluctably you have questions, don't hesitate to reach out to me. I'm happy to help, happy to engage, happy to answer questions. I don't doubt that I'm going to create more confusion than not. So again, just don't feel constrained by our brief amount of time in this session. If you have anything you want to talk about, just hit me up. And my direct messages are wide open as well for Twitter. So there you go.
There you go. And so thank you very much for being here today. I think this is pretty magical. Magic. Okay, so let's talk about what we're doing today. As I mentioned, Astra is really Cassandra as a service. Let's just keep it at that. But it's there for probably the thing that you don't want to do with Cassandra is run it. It's just operations. Running a distributed database. Yeah, that, like you said, Josh, that's not your core competency. No. Then right.
We were talking about pain earlier, right? I was telling you that I stubbed my toe and cried a little tear of agony, right? And it recalls the pain of running your own distributed database.
Yeah,
it's not something I'm interested in doing.
Yeah, it's a competency that it's not unattainable, but it's like, well, is that really what my business is?
Right. This is the stepping on a Lego of software, right? It's you can do it, but why?
Right. We could also create our own data centers, but why? And also things that are probably things that you don't even want to think about, like security, making sure your data is secure. And then finally, we have a lot of really cool features to allow you to do application development, and we'll touch on those a bit later on in this live stream. But it's meant to be a Cassandra for developers, and that's why we're here today. Go ahead.
I just said ooh-wee.
Oh, ooh-wee. Okay, you're like, wait, hold on. So this is what it's made up of, and so. Interesting facts, fun facts. Astra is Cassandra running on Kubernetes, and so we dog food a lot of what we already talk about with Cassandra and Kubernetes in Astra. So it happens, but because we're using Kubernetes and we get that portability, we can run it in any cloud, and so that's kind of a key part of this. We also include some really important dev tools using a Stargate project, which I think is a really cool name for a project, don't you, Josh? Yeah, but it gives you things like REST, GraphQL, but you can use more traditional Cassandra tools like a CQL console.
On the Spring team, we're not great with project names. I mean, don't get me wrong, they work. It's just that they're very right on the nose, right? So we have, if you want to create a web application that does some sort of MVC web framework stuff, you can use Spring MVC. If you want to do batch processing, you can use Spring Batch. If you want to do enterprise application integration, you can use Spring Integration. If you want to do security, you can use Spring Security. You see what I'm doing here? You see where I'm going?
Yeah, it's very literal, isn't it?
If you want to create boots, then you can use Spring Boot. Wait, that doesn't work at all. Well, okay, that's the exception. But basically, we're not great with names. So I really appreciate what you've done here with the
yeah, the theme. Can you see the theme?
Yeah.
There's a theme.
There's a theme.
Yeah, it's space. Space is a good theme. So the other thing that I think is really critical is running Cassandra can be a pretty expensive proposition when you start thinking about building out a huge cluster that you need to support your Cyber Monday every day. But we now have a serverless version of Cassandra running in Astra that essentially allows you to just run, to use what you need when you need it, and then not pay for it later. So that means if you're doing a lot of writes, you pay for that right now. When you stop doing the writes, you just pay for the storage. And that's a pretty radical shift in the way that people run Cassandra. And it's really super cool. It lowers your costs by a lot. And so you can get the same wonderful Cassandra experience at least half the cost. So that's just something to think about, Josh.
Yeah. So what is that? Like, what sorcery is that? How is that even a thing? So is it serverless? Did you just say like?
Yeah. Well, we've gotten into this point where we can, because cloud native technologies are about separating compute, storage, network.
Right.
We've componentized the way that Cassandra works in our Kubernetes cluster in the back end, so we can charge separately for compute, storage, and network. And when you're not using compute, then you shouldn't pay for it.
Fair enough.
And
checks out.
Yeah, and if you are doing a standard Cassandra cluster, usually you provision, say, 10 machines in your cluster that are continuously running 24/7. You don't need to do that anymore.
Not anymore. Cool.
Not anymore.
This is super cool.
So let's talk a little bit about, Josh, this is where you and I were really grooving on, and this is going to be really helpful as we get into the code, is just understanding the Cassandra data model methodology. If you will indulge me.
I cannot wait to hear what you're about to say, and I can't wait to later on explore this, and we can do that in the database that I've just gotten an email confirming has been created.
All right. I'm going to dig into this real quick, and then let's do it, all right?
Just sliding into your DMs.
Okay. So, all right, let's talk a little bit about Cassandra data modeling. It is a very important thing to understand at some level. And granted, today you have to understand less than you did, say, a year or 2, 3, or 4 years ago. But there's a mode of thinking whenever you do Cassandra data modeling, and it's really thinking about your application first and denormalizing data sets to be ready for application query time. So you start with your application, you build your models around that application, like what queries do I need to support it, and then your data will follow. So what would that look like in practice? Something like a to-do list, like this is how you pull out those queries. So I need to list every single task. I need to create a new task. Mark a task as completed or incomplete. These are all actions that will require some sort of a data model to support it. Today we're going to do a little demo, or we're going to use a database like you were talking about, CRM and ordering products. Let's think about like how would we design this application and what do we need to support it. And then really it's from there, taking that model, then we can go through this mapping, like, okay, we're going to have this application workflow, we can map it, and then we can start building the actual physical data model. There's a lot more to dig into here. If you want to do that, there's plenty of videos out there, but I'm just going over the high notes, and then when Josh and I get into this, it's going to show up. But this is what that physical data model looks like, and it looks a lot, Josh, it looks a lot like SQL, doesn't it?
Remarkably so.
Yeah.
Conspicuously so.
And
I wasn't but yeah.
Yeah, you were like, oh, this is SQL. No, this is SQL. This is Cassandra Query Language.
Awkward.
Super awkward. The thing that's a little different here, and I think that you'll notice right away, is there's no on the typing, there's no size components, and that's built by design. It's pretty flexible on size. Now, of course, Boolean.
Would you say that the types are web scale?
I'm gonna say web scale.
Okay.
Yeah. It kind of makes me cringe when I say web scale, but sure.
Ironically, though, can we just assume they all default to scale, web scale, size web scale.
Size equals web scale. Yeah, so like your boolean could be huge.
Exactly.
It's like that's the biggest boolean I've ever seen.
Yeah, giant.
So we're gonna walk through like building all. Well, I don't need this part right here. So whoops, we're gonna do this. Yes, we're gonna do this. We're gonna actually go through this process right now. So I'm gonna stop my screen share in a second here. So we're gonna walk through how to connect to Astra through Spring. So let me stop the screen share, and I'm gonna hand it back over to you. And let's just do this, Josh.
All right. Smart, why don't you? Okay, you can see my screen, hopefully. Babu. Okay, yes, good. So we are. I've got a database here. We need to build an app. This is you just explained that we're going to build database views for our app use cases. So it's an application database, right? Is that a fair way to think about it? So I need an app. We won't get very far without the app. So let's build something, right? I'm going to go back to start.spring.io. This is my second favorite place on the internet. Anybody who knows me knows that my first favorite place on the internet, obviously, is production. I love production. You should love production. You should go as early and often as possible. Bring the kids, bring the family. The weather's amazing. It's a happy place on earth. It is better than Disneyland. But if you haven't been to production, you can begin your journey here at start.spring.io. And what we're going to do is we're going to build a brand new application using Cassandra. So I'm going to use the reactive Cassandra support. I'm going to use Lombok to make Java just a little bit less tedious. But by the way, Java 16 is now supported. So we're going to wait that. Java 16 just dropped a couple days ago. It's now supported on the Spring Initializer. Let me ever so briefly, SDK list Java. It's always good to check the stuff on the day of your presentation. I think that's smart.
You should do it live. Yeah.
Always. Yeah. Okay. So SDK install Java. That'll be fine. Don't worry about it. It's fine.
No, it'll be great. Don't worry.
No fear.
We're doing it live.
Yeah, exactly. Worst case, I'll go back to 11 and it'll be fine. Okay, so we got a new application. I'm going to use Cassandra. I'm going to use Lombok. Okay, maybe I'll just add the reactive web something so that we have something up and running. And very good. I'm happy with that. Let's go ahead and hit generate. That'll give me a zip file that I can then. Oh, hey, you want default? I do too. Good stuff. So let's see. Java minus version. Hey, take your sweet time, why don't you? Wow, that was weird. Java.
Sweet. It's Java 16. You're there.
So here we go. There's our CRM. I'm going to open this up in my IDE. Don't be alarmed by this little command, this little alias. UAO is a little script I have on my machine. It just means unzip and open. It literally unzips the zip file and opens it in my IDE, which in this case is IntelliJ. Anything will work just fine, mind you, right? It doesn't all that much matter what you're using so long as it supports Java 16, the just released Java 16, and Maven and/or Gradle. So we're going to use Cassandra. There's default configuration in Spring Boot that draws from Spring data, and that support talks to Cassandra. And so had I an instance of Cassandra running my local machine, we'd be all set. But of course, we need to do better, right? We want to connect to Astra. Now, as you just started to explain, there's a wee bit more involved in running a Cassandra on Astra. A little bit more scale, a little bit more security, a little bit more. There's just more. It's a little extra. So we need to make sure that we.
It's extra. That's right. We used that yesterday. Yes.
Right. I'm gonna make that work. So we need to make sure that we connect to it. In order to do that, we need to use the spiffy new Astra SDK starter, right? So Cedrick was nice enough to help me. He was nice enough to help me figure out how to do this. I git cloned the code and built it and installed it in my local machine. Will this be in the repositories at some point?
Yes, for now it's on my repo, but we expect that to be on Maven Central pretty soon. You just are a beta user of this Astra SDK. So Astra exposes the regular Cassandra SQL, the one you just showed, but Astra also exposes new APIs, REST API, GraphQL APIs, pretty neat for people using JavaScript, for instance. And having an SDK is like I do the wrap up and read the specification of the API for you. You now have a fluent API to interact with Astra.
So let's, now that I've got that on my local machine and it's there, it's going to do a lot of the, there's a lot of work involved in connecting at first blush, right? So hello Astra. So I guess I need to connect, right? And so that's not going to do something useful unless I have some credentials or some sort of authentication. Is that fair? So where do I go now?
Yes, you need to create a token. So go back to the database and find the tabs named Settings.
Okay.
And there, see, you can now create a token. So I want you to create a token with the credentials like database admin, no fear again. And
admin user?
Yeah, it's okay. Admin user is totally fine. Yes, you created the token. And now, you download that CSV. You make sure that you copy the values somewhere because they won't show up anytime soon. It's quite secure. So please use that. Save that token somewhere.
Neat.
This should be a fairly common practice if you're doing any kind of cloud databases. You need to be able to store the credentials and create tokens to do this. So this is just a good general practice.
Indeed.
And careful where you put it. Right. Don't put it in your Git.
I'm going to terminate this later, but it's expecting certain properties in a certain place. In the Spring Boot world, you can start by putting your properties in application.properties, and there's all sorts of other properties to which Spring Boot will respond. And your IDE will no doubt know about some of them if you're using anything in anything like Visual Studio Code or IntelliJ or Eclipse or anything. They all know about the properties sets that are available. But what properties are supported by the Astra SDK starter?
Because you imported the Spring Boot starter, you should have the auto completion available. So you should go to application.properties and start typing Astra dot, and you will see that you will need to provide the database ID, the cloud region, your token, and the key space.
Database ID. Where do I get that from here? Where do I get that?
Okay, it's so database ID. You will
go back to your pass. Yeah, there you go. Database ID is the cluster ID in this case.
Exactly, cluster ID.
Good. And Astra application token.
Correct.
Seems like I would have that. That's this bit right here with the Astra blah blah blah.
Astra CS something, right?
Okay. And we want Astra dot cloud region. That's
yeah. Where are we pointing your code? It's right there.
Exactly.
1. Okay. Whoop, 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 whoop. Okay.
And that's it.
That's it.
Walk away.
Yes, you can still even put the key space. Yeah, the key space as well eventually.
Okay. Now keep in mind, these are properties in Spring Boot. I can support them. I can plug them in through application.properties. But as Patrick just said, as he just advised, you shouldn't check this into your Git repository. So keep in mind, Spring Boot will do just fine if you store this outside of the jar or if you put it in an environment variable. So for example, you could have an environment variable that look like this. And in your shell script before you run the program, if you said export Astra key space, that'll be the same as providing it as a property in the property file, right? So this actually, if you check in the code, don't do that. But if you check in the configuration here and you have like a default local cluster or whatever that's for whatever, and you want to override that at runtime, you can just use environment variables, and those environment variables take precedence over whatever's inside the jar when you run the program. So you can plug that in. You can have production credentials that override default inbuilt credentials, for example.
Yeah, Josh.
Yeah, and the token.
As a matter of fact, the SDK itself looking for system variables, environment variables, and only then, if they are not provided, we look at application.properties.
Ah, sweet nectar. So that makes perfect sense. So both the Spring Boot default and the Astra default
Correct.
is to prefer external configuration. Okay, so it feels like I got something here. What's next? Can I just start it and run? Let's just see if that works.
Yeah, it should. Do you have the Astra client bean? Yep, should be okay.
Let's see some magic happen.
Release Java 16 is not supported.
Oh no!
Wait for it. Don't worry, we got this.
So I knew it was gonna come and get you. All right, just a quick configuration change. Nothing to see here.
Oh, come on. Do I not have accept? How do I get well, okay, sure. Apply. Okay. Will that run? Will it work? These are the questions. It's indexing JDK 16. What could go wrong?
Good thing you got a fast server. Hey, it's compiling. Come on. Oh.
Awkward.
So close.
At least.
I mean, it's fine. I can just do 15. Everybody's happy.
It'll down convert.
Yeah, Java has that neat trick where it can run despite a week's worth of time and changes, quite unlike the Node.js ecosystem. Okay. Okay, what is that? It's sorcery. So Maven reimport. Module settings. Oh, 15. Retreat. It's bad television.
This is live coding.
Yeah, at least we know it's not recorded.
Nobody else is seeing this. It's fine. No, so
good.
I'm using Java 15. Don't do that, right? You should be using Java 11 or the current supported version of Java, which is 16, which I'm sure will work if I just spend a second on it later, but certainly not now, not before all of you while you're waiting patiently. So I've just restarted the application. It took a fair amount of time. Look at that, 6 seconds. What's going on? So it looks like it's connecting to a lot of stuff. What's it doing there?
Indeed. So, Astra is cloud service, and you will connect to Astra. To connect to Astra, you need to open a two-way TLS communication. To do that, you need strong authentication. You need certificate. This is the only way to be sure that you are very strongly authenticate. And so you need to download some kind of zip locally and to enable that connection. The SDK will do that all for you, and it will connect to this Cassandra for you. Now you are ready to go. You do have the SQL session open and connected to all your nodes on the Astra side. You're good to go. But indeed, as you stated, when you start a stateful app, you need to connect to the database, and it takes a few seconds.
Okay, so behind the scenes, and that makes perfect sense, right? It's a hosted cloud database. In theory, I'm talking to something in in Virginia in the United States, which is 3,000 miles away, and it's doing a lot of stuff. So that's fine. Makes perfect sense. It's downloaded something called a bundle. That's the token you were talking about. That's the certificate and all that stuff that I need.
Yeah, it's all the goodies that need to be there to make a secure connection. What's really cool at which Cedrick has set up here is that it just does all that behind the scenes. That takes a little time because it has to download it.
Right.
You could do this more manually. You could download this yourself and put in the parameters. So if you wanted to make this faster, for boot time, then you could just do those steps manually. This is a very hands-off type client.
I like hands-off. So okay, so now we can focus on data modeling and data, right? That's what I care about.
Let's build an application, yeah.
Okay, so here's what I'm imagining, Patrick and Cedrick. I'm imagining a nice, clean UML diagram that looks something like this. You just tell me how close I am to the finished product, okay? You just stop me when I'm ready for production. You just tell me when I'm done, okay? So I've got a customer object, nice clean object with a key, a primary key, like in my SQL database, and I've got a string name, and I'm going to have a one-to-many relationship with my orders. Now, again, just stop me when I'm done, okay, Patrick? Just tell me when I'm done with this description, with this code, and I can just go ahead and hit deploy. Tell me when that moment.
Well, I think there's a couple of things in here. So you're doing a one-to-many relationship. So
there you go.
One customer has lots of orders, right?
Yes, sir.
And I think one of the things we need to stop and just for a second to talk about is the ID number. One of the things that's really important around like a distributed system like Cassandra is we rarely use integers for ID numbers. We use UUIDs.
Okay, So you're saying that's not going to work. Okay, I'll just
it'll work, but it's hard to generate a sequential integer in a distributed system,
Right.
especially large scale. Like if you had 1,000 nodes, how are you going to synchronize that sequence?
I see.
Yeah, it's very expensive.
Yeah.
So that's actually a thing that, like, let's just stop here for a second and call this out. This is how we learn to scale, right? This is a moment where we think about what we're building and why we're building it. And so when we use a UUID, we're embracing this idea that, we're going to be using a distributed system, and those norms mean we just stop doing coordination because it's really super expensive. So let's just keep going, but I think we're going to find more of those.
Okay, so but otherwise, if I just change this to UUID, I can have my foreign keys, and that works just the same as before. That's true, right? I mean,
yeah, what we're going to do is we're going to denormalize and map those into a customer table. But keep going. You're doing good.
Okay, so it's going to be a denormalized thing, something like customer orders. Is that more the speed? Okay, good. So private UUID ID. Okay, that seem legit?
Yep.
Okay.
Customer ID, because we're going to want to have a UUID for customers, right?
Right.
And then we're going to have a UUID for an order.
Okay.
An order ID.
And then maybe the name of the customer, something like that. No?
Yeah, exactly. So now this is really what we've just done here is set ourselves up for a one-to-many relationship in a denormalized table. So this is correct from a Spring standpoint. So now we just need to create the data model itself. So why don't we just do that?
Okay, so I'll go back to here and go to the console.
SQL console. Yep.
Okay. Yep. Groovy. I got this. And
so when you're in SQL console, you're gonna this is the command line for your database. And one of the first commands you're going to have to do is switch to that schema that you created, or that database, or key, what we call key space. And if you recall, that was called CRM. So let's just use a use CRM.
Okay.
So now we're in there. Now we can create a table.
Okay. So I'm going to go ahead and just write regular SQL code. You just stop me when I'm doing it correctly, okay? Just stop me when I'm done.
Stop me when it not exists. Yep.
By customer, right? Since we're creating a thing that's not two separate tables, it's one table. I need to create that table if it doesn't exist, and it's going to have a customer ID that's going to be a UUID. See, is that check out so far?
Yep. Okay. Looking good.
Going to have an ID, an order ID,
which is a UUID. Yep.
Okay. A customer name, which is going to be a text field. Yep. And it's going to have a
primary key.
But this is okay. So this is a primary key. And what's the primary key, Patrick? What am I doing here?
Okay, so the most important thing you need to know about Cassandra data modeling is the primary key and what it means. So what we're going to do is we're going to create a one-to-many relationship here. The one is the customer, right? So there's one customer, multiple orders.
Right.
The way we describe that in a primary key, that customer ID is what the first thing in our primary key, which we call a partition key.
Yeah.
And a partition key, what that does is it allows us to, this is what happens in a distributed system, and a lot of them do this, but the partition key is what's used to actually locate the data in a large cluster. So it's kind of like the address of where that is.
Okay.
So Cassandra is a distributed hash map, more or less. This is the key to that hash map. So
the key would be the customer ID.
Customer ID.
And then the specific address of the particular record would be the order ID.
Right, and we call that a clustering column. And so when you use a partition key with a clustering column, that is a one-to-many relationship.
Oh. So what if I want to have multiple, like, what if I want to have a composite, like, partition key?
Like, yeah, so if you want to have a customer ID plus something else as a partition key, you just put parentheses around it.
Okay, like that.
Yeah, so you're basically you're protecting that partition key with parentheses. Now you can leave it like that. That's perfectly fine. Just it's very explicit at this point. Okay. But this is the
what you get if you do like a left join. We're just skipping straight to the left join state. But as you know, whenever you've done a left join in like a SQL database, you get back for every row in the end part of the left join, you get back redundant copies of the data in the one record. So the customer name, for example, is going to be, am I storing the customer name multiple times? Like, what am I going to do there? I don't want to have to store it for every single record of my orders.
Well, all right. So if you wanted to just keep that one record, I know where you're going with this. It's like, it seems like now what I'm doing is I'm just repeating myself over and over again.
Yeah.
First of all, the thing that you should know is that the compression algorithms in Cassandra are pretty efficient, and it won't be that much of a waste of space if it's repeated. But in order to be the most efficient, using something like a static here, so customer name, text, and then at the end put static. What that means is that you're only going to have one of those per table or per partition key. I'm sorry.
Okay. Anything else? What goes at the end of this?
You can now, in this case, we're just using UUIDs, so order isn't as important. But if you wanted to control the order of your table, let's say the order IDs were a sequential number, or maybe they were a timestamp. You can use this. You can use there's a clause that you can put in there to change the order. So yeah, with clustering order by is what it's, there you go, order by. And what that means is that you can say, hey, this particular clustering column should, instead of being normal collating order, like ascending, make it descending. Now, with UUID, makes no sense because it's pretty much a random number.
Right.
But again, like if you're using time series data, really loves this. Like you can reverse time order things in your table, that sort of thing. So you could just say descending.
Okay, like that.
Yeah. And when you do this, what you're doing is because you're building the query ahead of time for your application, you're adding an order by in that query initially. So whenever you do a query, you get the correct order.
Can I ship it?
Yeah.
Oh, that's so satisfying. What just happened? Okay, so
let's let's just do a select on the table, or you can do it. Yeah, you can do describe on the table.
Okay, I've got a table. Neat. Okay, so select all from.
And that'll just give you a nice blank thing. So the coloring, the red means it's a partition key. The teal, the shark color means it's a clustering column. And then because it's white, it's blinding white bold, that means that it's a static field.
And these are also, if you look at it, it's red, blue, and white, the French le drapeau tricolore, you know, the French cut.
Cocorico, comme on dit en français.
See?
So good.
Let's switch in.
So let's insert some data here real quick.
Okay.
Or do you want to do that in your app, or do you want to do it manually?
Always in my app. It's where I start, it's where I end.
So let's do it there.
Yeah.
All right.
Makes more sense. So okay, I think we need to talk to that database. We've done the hard part. I think we've got the model. Now I think we need to take our Java code and map it to that, right? And so what I want to do is I'm going to use Spring Data. Spring Data is an umbrella project that has a number of different integrations with a number of different database technologies. None so nice as Cassandra, of course, right? Cassandra, definitely the best, thing to say at this point, right? It's the best for I don't know, there's context, but for so many different use cases, Cassandra's a great choice. We want to use the integration with Cassandra, so I need to map my object to
because we expect to have a lot of customer orders, so we need some web scale.
Right. Yeah, exactly. Scale is very important, You know who else knows about scale?
Well, what's that?
Who else knows about scale?
Everybody loves scale, right? It's like, if you think like who uses Cassandra, if you have a cell phone in your hand, it's probably being backed by Cassandra right now. Is it an Apple phone? Yes.
Yeah.
And just recently, like Huawei did a big presentation at ApacheCon about how pretty much all of their backend systems for Huawei are running Cassandra. I mean, I think between Apple and Huawei, there's only a couple of cell phone providers left.
Just well, that does account for literally billions.
Yeah, and they're using a lot of Spring.
Yeah, exactly. Both organizations. Okay. So now what? I've got these IDs. I need to map this to a primary key column, right? So there's these nice annotations in Spring Data for mapping, and I can use I want to say that this is a column called the customer ID. And what else? What is this ordinal business?
That just points out like the position in the primary key. So like I said, the position when you look at if you were looking at our data model and it says primary key,
right?
It's the first position in the primary key is always a partition key.
Okay.
So if we have an ordinal of 0, that you're basically saying, yeah, this is the partition key.
Cool. And the type, what did I just do? Which one am I
partitioned? Yeah.
Cool. Okay, so got that.
And then we could change this to
order ID. And this doesn't seem like it would be.
Yep. And then we're going to change that to clustering.
Can do. All right, good.
Clustered.
So that's it. That's the whole thing, I guess. I need to create a repository now. And to support that, I'm going to create a bean here. So I'll say, or an interface rather. I'm going to create a repository. Customer repository extends reactive Cassandra repository. Now,
that's a lot of words.
Sorry?
I said that's a lot of words.
When we talk about Spring and we talk about reactive programming is a way to address three main concerns that you typically face when you start building cloud native services. Ease of composition, robustness in the face of topology changes, service outages, and so on, and resource efficiency. So composition, efficiency, and reliability or robustness, right? And reactive programming does that by giving us a programming model that allows us to write code in such a way that we're never ever sitting on a thread waiting for the next byte to arrive. We can ask for bytes from our data source, from our socket, from whatever we're talking to, but we don't ever just sit there waiting. We jump off the thread, relinquish the thread, return it to the thread pool, let the runtime do things with that thread in the background, and as soon as that request that we've asked for arrives, then we get put back on a thread, we get to process it, and as soon as we're done, we jump off the thread again, right? So we're never ever just idle. We're never just sitting there, waiting for something to happen. And this allows us to keep our CPUs maximally utilized, right? We want to keep our services hopping, always close to 100% utilization. So reactive programming requires that you rethink the way you write your code. It's not going to be just the regular collections or arrays, right? These are different data types, but the benefit of that is that it's just one kind of thing. So no matter what the shape of your data, whether it's 2 records that arrive immediately, or if it's 1,000 records that arrive over a slow trickle over the next year, or if it's a billion records that all arrive in the next second, it doesn't matter. You still use a reactive stream type called a publisher. So I need to map this repository to these reactive APIs. And this interface has support for those types. Publisher, Flux, Mono, these are all reactive types. Mono and Flux are specializations of Publisher. Publisher is kind of like completable future, except that you can have more than one value. So instead of getting a callback for the availability of just one value, you can get a callback for every value that comes after that as well, be it an unlimited amount of data or just 5 records or anything in between, right? Or 0, 1, 2, 5, a trillion, infinite, etc. So we need to also describe in Spring Data, this is the entity, this is the primary key type, and that primary key in our case is just a primary key class. So primary key class, and of course, it's going to have these 2 things, right? There we go. So I'm going to put those in there. That's the basic repository, and now I can use that to write some data to the database. So I'm going to go ahead and initialize our database here in this application runner. This is a Spring Bean. It's a callback interface that will be run when the application starts up. So here, I'm going to just initialize some data. But before I do that, I want to delete everything so we have a clean workspace, so to speak. I'm going to delete everything. But notice that what I've done here is that if I call delete everything, if I say to delete everything, it returns not void, but mono a void, a wrapper, an asynchronous wrapper around void. In order for me to actually see this do anything, quite like the Java 8 Streams API, you need to invoke a terminal function, as they say. So I need to say .subscribe. The trouble there, friends, is that subscribe itself is asynchronous, right? Or it can be. You don't have any guarantee that this line will succeed and finish or whatever before the hello gets printed. So you might actually see hello being printed and then the results of that subscription. So then we're going to write some data to the database. And what I'm going to do is I'm going to create just a reactive stream of names, and we're just going to create some sample data here. So private final string Patrick equals Patrick. We want Josh, that's Josh. We're going to go for, who else is neat? We've got, let's go for some Spring team engineers. Madura, she's a legend. We've got Shin, she's another legend. So some Spring people and some data people and me. I'm a Spring people kind of. So we're gonna go ahead and put these people in a list here, or a stream, all right, an in-memory string, stream literal, and I'm going to say for each one of those names, I want to take each one of those names and write it to the database, and I'm going to write a bunch of orders. I'm going to synthesize some orders. So I'll say add orders for, and I'll just pass in the repository there, and I'll pass in this name. And so we'll go ahead and create that method there. And what I'm going to do is here is I'm going to actually I'm going to add some, I'm going to make up some data. I don't have real data. I'm not cool like that, but I'm going to go ahead and synthesize some. So I'm going to create a method that returns 0 to n orders for one customer. So I'll do this. I'll say var customer ID equals UUID.random ID, right? And I'm going to create a list, and I'll say new array list of customer order. Okay, and for var I equals 0, I is less than some random number there. Okay, whatever. And then we'll just do list.add new customer orders, passing in the customer ID there for the first thing, passing in another one for the random, for the order ID, and then the name, right? So I'm actually just creating a list of orders, adding it to the list, and then I want to actually just write the whole thing out. So I'll say return repository.save all, passing in that list of records, right? So that's going to create a reactive stream of the results that have been saved. So the result is that this operation, I'll start with a bunch of string names, and I'll get back a stream of persisted customer orders. Okay, and those are the writes. So now I've got two different things. I've got the delete, right? I've got the writes, and then what happens after the writes? Well, I think I want to just see that everything is working. So I'll get all the data back. I'll say, okay, repository.find all, and you get these free methods that are supported by that repository. So let's just see what that looks like. All. Okay, good. So now I've got these three things. One has to succeed the other. Delete first, then write, then get all the results. And if it happens in any other sequence, it's indeterminate and things get weird. And the next thing you know, your Schrodinger's database, and it's bad. So I'm going to make sure I use these operators: delete, then asynchronously and potentially, on a different thread, then write, then get all the data back, and then finally, as those results trickle back in, I'm going to print them out, right? And I could, the subscription there, I have an overloaded version that allow me to operate on the data that gets sent. But what I want to do is I just want to print out every single customer order that gets written here in the that gets returned in the all stream there. So I'm going to say system out, and this is going to be the repository, and I'll just print out the result there. So co.toString. Let's run this. I think that'll give me something, hopefully.
I'm waiting for it. Just click it.
Do this.
I mean, now that you're running like Java 15, 16.
Yeah.
15.5.
Awkward.
Yeah, that's all right.
There's the data. So that worked, right? We've got the data. You can see it's, like you were saying earlier, it's denormalized, right? So I've got multiple customers, but I'm not storing multiple customer names. It's the database is giving me that because it's smart. It knows what I want. But
well, that's what you're storing it. And then what you're saying, please store this for me. The database is like, I got this.
Yeah. So I got multiple customer IDs that are all the same for a given name over here, but different order IDs. Right. So that's cool. So I was able to read the data using the repository. The nice thing about Spring Data repositories is that you can actually provide your own finder methods. These are custom queries based on your particular use case. So suppose I wanted to create a finder method to just find data by its customer ID. I could do customer orders, find by customer ID, and then pass in UUID customer ID, right? And that would actually synthesize the name of the query. It would derive the query from the name of the method, and I can just use that. Right? So let's try that instead. Here, instead, I'll say. One of these IDs that we've just persisted here. So I'm going to go, I'm going to say write dot take, need to find the first one, and then I'm going to get the CO, and I'm going to map it to the customer ID. And what does that give me? That gives me a stream of UUIDs that has one result in it. So I'm going to say, given that one result, I then want to find that object by its customer ID. I'm going to actually then ask the database using the repository. So then I'll say flat map UUID repository.find by customer ID, passing in UUID. And this gives me now, even though it's a stream that is potentially unbounded because we've only taken one result, it should just be the first result that comes back. It doesn't matter which one. So we'll actually get just by ID there. And in this case, I want to print it out as well. I'll say, okay, by ID, do on next. We'll say all, here's by ID. Okay, good stuff. Let's run this again. Okay.
I love seeing that.
Recompiling. This is the hardest part, is the compilation.
The recompile is the hardest part. I think there's a song in this.
There it is, and it should be okay. So by ID, there we go. I only searched for the first ID that that I chose, just any random ID in the stream, and you can see all the other ones are there, right? But I have just one by ID here, and that's the results there. So that's good. I can use the repositories to get easy access to my database. But there's actually a lower level API that we can use here called a Reactive SQL Template. So if you don't like the high level repository and you have some particular use case that is better served by low level access to the APIs, you can use Reactive SQL Template. Okay. And in order to build this instance, you need a reactive session factory. So reactive session factory. And we can just inject this dependency, this bean. We're going to inject it here, template, and we can use that now to.
So what is that going to do?
Well, that's going to give us a lower level API that we can use, because I'm just pulling data out of the database. We already did we reset the data. We're deleting the whole database. That's not slow, by the way. That's not fast, by the way. I'm just doing it for our demo. Then I'm going to write some data, and then I'm going to get all of the data just to show that I can. I'm going to get data by a particular ID. But then if neither of those approaches works, I'm going to now do I'm going to use the Reactive SQL template here, template.query, and I can just actually issue low-level queries. I can say select all from orders by customer. Is that right? And I can actually provide a row mapper, right? And this row mapper is going to return.
Oh, I see what you're doing here. Yeah, okay. Get a little more into it instead of just auto magic.
Right. I can actually control how I map and to what I map. the results. So I'm given a low-level row, and I can, in this case, I'm just mapping it to the mapped object, but you could map it to a DTL or a view or something like that. So row.get UUID, it's called customer ID.
And this might be a good point to bring this up too, Josh. One of the reasons we used UUIDs is this asynchronous type coding that we're doing here, right? It not only is important for distributed systems, but like when we need order, we use that partition key with cluster column. Because of like any one of these rows of data could be stored in any server in the cluster. There's a lot of like, first of all, that's a superpower that can make your queries go a lot faster because it can run in parallel. But it's also like this order dependency. Like you're asking for a specific customer ID and then all the orders with it, that will be in order. But if you ask for a group of customer IDs, there's no order guarantee in that.
Right. So let me rerun this again. Now I've got a SQL query just directly. So I've got 3 different ways of pulling data out of the database that I've then written. And by the way, the one thing I didn't really show here is when we wrote the database, there is all 3 nodes tried for the query failed. What does that mean? Select all from orders by customer. Is it orders by customer? Is that not valid syntax? Customer ID.
What was the error?
All nodes failed exception. Failed to interrupt compactions. Something
happened there.
Let's retry.
Yeah, let's try that one again.
What we got? Bet it's my Wi-Fi. Neat. Yeah, it's just my Wi-Fi or something. Okay, so we've got now 3 different ways of pulling the data out using Spring, right? And that's fine. We didn't talk about writes a lot. I mean, you saw that I wrote some data, but what happens if I want to do an update? One of the nice things that I'll bet people would like to know about is that you can actually create a version field, right? So private, there's an integer, I guess, version. And this how does that work? It's something called optimistic locking. What is that?
Well, optimistic locking. Okay, so then this is one of those things that whenever you have an order, like you have a guarantee that you need to put into a distributed database, there are mechanisms to allow you to do this. We have this thing called a lightweight transaction, which essentially this is like whenever you need to check something, like do a read before a write. So check and set. A lightweight transaction also sets up an exclusive operation in a Cassandra cluster using Paxos. So for instance, if you need to make sure that you're the only process that is inserting data into for this record, like you don't want to have 2 Joshes in there, just one. There must be only one.
Yeah, it's enough.
Yeah, that's plenty. But lightweight transactions, what they do is they create a Paxos lock to make sure that it's exclusively writing that record. So if any other process comes along later, or in like a microsecond later and says, I want to write a Josh record too, it'll get blocked. With an update, it just makes sure that record exists before it updates it.
Cool.
Cassandra has this great feature that it doesn't check. If you say update, it'll just update it. It won't look to see if it even exists or not. And if it doesn't, it'll insert it for you.
That's YOLO mode.
It's called upsert, but YOLO works too.
Yeah. Okay. Groovy. Okay, so we've got that. There's a lot of cool things we could do here. Now, this is all sort of in the Spring ecosystem, but again, there are so many other views or accesses for the data. So here I'm just using this stuff, but let's suppose that we wanted to actually talk to some of the other views of the data. So let me create another listener here, application ready event. Okay, Astra client, Spring data. And here I can actually inject the auto-configured Astra client, which gives me a whole bunch of superpowers that go above and beyond what the Spring data integration has. So here I can see Astra client gives me access to the REST API. So I can, in theory, just talk to the database through REST, which is very convenient, right? I don't have to use Spring data. If you're not using Spring, and again, don't know why that would be, but if you're not using Spring, you want to talk to the REST API, there's this. That's cool. You have the DevOps API, which allows me to administer my account, my Astra account. I can actually, find databases, delete them, create new key spaces, do all that kind of stuff, that administrative stuff from the command line, from the code, dynamically in response to whatever I want. There's a document API. So if I want to treat my Cassandra a document database, I suppose that's what this is for. Is that the idea?
Yeah, so because we're using Stargate to be a data service API gateway, Stargate has the ability to create document models, a document model, data model on top of Cassandra. So if you're going to do like something like traditionally what document models do, which is just store a blob of JSON as a document, we allow for that inside the API. This is a pretty radical change for Cassandra, where now you're checking out all kinds of stuff here. There's Stargate. Whenever you go into document mode, you're no longer in data modeling mode. You're just storing a JSON blob and you're using it that way. I think there's a lot of databases I will not name that do something similar. So it's a very different way of doing Cassandra, and probably a whole talk in itself right there.
Oh yeah, absolutely. And it's open source, so I encourage people to check it out. This is useful. You can use this. It's not exclusive to Astra. Is that true? Like I can use this.
Yeah, it's actually a part of the Cassandra project, which is Cassandra on Kubernetes. There are other databases that will be supported with it as well. So yeah, it's not exclusive, completely open source, and we'd love you in the community.
And there's actually GraphQL support, and there is right now Spring Projects Experimental here. There's actually experimental work that we're doing around, yes, you guessed it, GraphQL.
GraphQL, because it's the cool kid now.
Right. And I can also do, I think I saw something in here, didn't I? Where would I have seen that?
Not in here.
Yeah, so you go to connect.
Okay.
Oh, I see. Oh, you see.
Connect.
Yes, okay.
Go to GraphQL. Yes, and start browsing this page. There is a GraphQL playground for you there.
This one?
The link.
Oh, there. Look at that. So I can actually interact with because of Stargate, I can now interact with my Astra data in terms of the GraphQL APIs. That is so cool. That is really cool. And of course, GraphQL is great because you can federate it. So now, not only have I accessed, not only have you solved the access problem here, but you've also solved the federation across multiple discrete services problem, right? Just in one fell swoop. That's so cool.
Yeah, and that's, the thing I have to appreciate about GraphQL is it allows you to be a little more expressive than REST, but gives you some of the same modes.
Yeah.
I can see why there are some really cool things happening in GraphQL, and I'm happy that it's supported out in Stargate, and going forward, it's just another way of getting data out of Cassandra. But it's got a huge potential.
Huge, amazing, really, really, really cool that you've got this. What if I wanted to create a API? What if I'm not using GraphQL, but I do want some sort of schema for my API? Is there something?
So yeah, you are in Connect. So now go to either Document API or REST API. So just the tab above or below GraphQL. Yes.
Okay.
And now you can click on the Swagger UI now. So just a link there. Here you go.
Nice.
And now you can use all the endpoints in the web, just providing the app token you generated before, and you can play with that. But as we told you, the SDK will wrap up all that code for you.
That is so cool. So I've got so many different ways to connect to my database, from low-level Java code all the way up to just give me a Swagger endpoint and I'll generate a client automatically, plug in a token, and I'm off to the races. That is neat.
Yeah, it's really it is meant to turn Cassandra into more developer-friendly database. And like, if you're writing Spring code, you can write front-end code at this point and interact with Cassandra. But
it's just a gateway.
It's just a gateway. But I mean, I think you touched on this early on. Is my business is not running a database.
Nope.
So why don't we just use a data service?
Well, your business is technically.
Yeah, no, for DataStax, right? Yes, it kind of is. I can't say that with a straight face, but You're, you, the royal you, is probably not. Yeah. All the people out there listening, you're probably not running a database company.
Knock on wood.
Yeah, and I don't recommend doing it. It's hard.
Yeah. Look at him. Just look at him. He's 27. That's what it's done to him.
And just completely ruined. Yeah. But I do it for the people.
Yeah, and
it's good time.
Yeah, so we do have a pretty good question. I would like just to enter 1 second regarding Stargate. We had that question. Okay, Stargate is a gateway, but is it competing with existing API management system? Like APG, Software AG, Layer 7, all Kong, all these API management system. Well, Stargate is simply exposing APIs on top of data. But we do not provide the features from Kong like monitoring, throttling, stuff like that. So both are complementary. It's not one against the other.
Oh, that said, if you are looking for an API gateway, so this is where we get into some trouble because this is a data gateway. It's going to give you APIs to talk to your database, your Cassandra database. There's also network gateways, which is all about the routing of bytes on the wire. But there's also API gateways, which deal with things like incepting a token for security purposes, doing resource servers, doing retries, routing, all that kind of stuff. For that, you should definitely check out Spring Cloud Gateway, which is like Kong or Apogee. It's 80% of Apogee. It's Kong. It's 100% of that basically, and it's built on the reactive API, so it scales very well. It scales at the same extent as the code I just wrote.
Basically. Well, and that's we've just built this whole story around scale, right? Yeah. You're using Spring, Cassandra. Your scale's not going to be the problem.
It's not the problem anymore.
No,
there's other problems now. Think about those.
Yeah, understanding your customers and building the right product. Let's make that the problem.
You've got the DataStax team have a whole team of people that have worked on making Cassandra easy to operationalize, and it's already notorious for being infinitely scalable, right? That's the thing that stands out about Cassandra. It's always been just scale's never been the problem with Cassandra, right? That's not the issue. Running it wasn't fun, but you took care of that with Astra. So now what's the complaint?
Yeah, I'm sure someone will say maybe potentially it's having to do data modeling, and maybe if you just want to use a document model and not have to do data modeling, you could do that.
Sure.
Yeah. So that's true. Well, I think we're at a point where we should wrap things up.
Yep.
All right. Cedrick, you want to share my screen, or maybe it already is? I can't tell.
I learn more. Who's sharing? I think it's
I am sharing.
So go for it.
All right, I'm going for it. I just want to wrap things up. Thanks everyone for being here. Josh Long from Spring God, thank you very much for being here.
Thank you.
Remember Josh at joshlong.com.
Yeah, at Starbucks Man. Patrick, so great to talk to you, and Cedric, so great to talk to you. Patrick actually did an episode, the poor schlub. He did an episode of the podcast, and so did Cedric, for completely different reasons at different times, completely unbeknownst to each other, I think.
Bootiful podcast. Yep.
Podcast. Join me there every week. I talk to somebody who's smarter than I am. Low bar, granted, but it's an always good conversation.
There is a really good conversation. So just a reminder, if you look on the slide, Astra, you can try it for free all the time, $25 a month. I mean, that's pretty useful. That gives you 30 million reads, 5 million writes, 40 gigs of storage. Yeah, that's a lot. We're a little crazy about this, but all right. But also on the open source side, we really encourage you to get involved in the Apache Cassandra project. We have Cassandra project if you were interested in running Cassandra on Kubernetes. The Stargate project, which I think we really showed off a bit today, another open source project. We'd love you to get involved. Again, with DataStax developers YouTube channel, if you want to hit subscribe, there's always good content in here. I'm sure we're going to get Josh back because I think we found a couple more things to talk about.
One or two.
Yes.
Oh, yes.
Let's do some more. Add two more resources. Start.spring.io for all your Spring Boot starters, and then spring.io/video, where you'll find ample videos on Cassandra and data and all sorts of stuff, all things Spring. We have more subscribers on the that spring.io force video takes you to our YouTube channel, which in turn has more subscribers than the official Java channel, for example. It's very, very, very active, very, very popular. So join me there, join us all there.
That is fantastic. All right, everyone. Thank you very much for joining us. And I think we're done here.
One more thing.
Oh, one more thing.
I just remembered. Today, we just announced that the call for papers for Spring 1, our big tentpole conference, is open. So if you want to talk about Spring and Cassandra, we would love to hear from you. Submit away, please.
Ooh. I know what Cedrick and I are doing after this.
Oh, yeah. I hope so.
Yeah, I may have a SDK and a starter to propose. Maybe.
It'd be a great time.
Good reference used by Terschlong. Okay. Accept it. All right.
Cool. All right. Well, now that everyone's going off and filling out their CFP, I think we can say goodbye.
Yes. Thank you very much.
All right.
And
thanks,
goodbye.
everyone.
And as always, don't forget to click that subscribe button and ring that bell to get notifications for all of our future upcoming